it does not change much. Then there is a material gallium arsenide also, which is a semiconductor which follows a non-linear relation of voltage versus current. It is a non-wave conductor and it sometimes shows negative resistance also. So when I talk strictly about the conductor, then for conductors or for semiconductors also, the relation is given by delta R is equal to, approximate relation it is, delta R is equal to R naught into alpha into delta T. Delta R means R final minus R initial will be equals to R naught. R initial is basically R naught into alpha into delta T. Alpha into delta T. So this relation you can remember. This is an approximate relation, always remember. The actual relation will be R is equal to R naught e to the power alpha delta T. It is an exponential relation. Even if you will plot the resistance versus temperature difference for a conductor, you will get it an exponential relation. But if you will do the approximation, you will get this relation as R final minus R naught is equal to R naught alpha delta T. Here please remember alpha is called as the temperature coefficient of resistance or resistivity. And R naught is the resistance taken at reference temperature. That reference temperature in many standard books is given as 0 degree Celsius or 20 degree Celsius. So R final minus R naught will be R naught alpha delta T. R naught can be written as the reference particular temperature. Understood the logic? The resistance at the reference temperature will be given by R naught. And if you want to find the resistance at any other temperature T, then you can find the resistance by giving this formula. I hope this particular concept is clear to you. Like let us suppose if you take this particular concept in which at 0 degree Celsius the resistance is given as 20 ohm and the wire is having alpha of 10 to the power minus 4 per degree Celsius, then you have to find the resistance as 20 degree. So you can apply this particular formula. And first of all, check whether alpha delta T is much lesser than 1 or not. If alpha delta T is equal to much lesser than 1, then you can apply this approximate formula. If alpha delta T is not smaller, then you have to go by the actual formula. But in NEET classes, generally this particular formula is not required. Generally, whatever data they will give you such data that alpha delta T is much lesser than 1. You can directly apply this formula and get the answer. I hope this concept is also clear to you. So let's move to the next concept and let's talk about now the concept of electrical power. Okay, these questions are also given to you. Let me dictate you these questions also. The resistance of a platinum wire is 5 ohm at ice point and 5.5 ohm at steam point. Ice point means what? Ice point means 0 degree Celsius. Steam point means 100 degree Celsius. So at 0 degree Celsius the resistance of the wire was 5 ohm. And at 100 degree Celsius, the resistance of the wire was 5.5 ohm. And they are asking when the wire is inserted into a hot tub, then the resistance of the wire is 5.8 ohms. So you have to find the temperature of the tub. So again, I will use the basic formula R is equal to R naught 1 plus alpha delta T. So at 0 degree Celsius, R naught will be equals to 5 ohm. And at 100 degree Celsius, it is 5.5. So I will apply 5.5 is equal to 5 into 1 plus alpha into 100. From there I will get the value of alpha. Then what I will do is at T degree Celsius, which is the temperature of the hot tub, I will apply RT is equal to 5 into 1 plus alpha T. From here also I will get the value of alpha. I will equate these two equations and I will get the value of temperature. So temperature will come out to be 160 degrees Celsius. Okay, now let's talk about electrical power. What is electrical power? Electrical power is basically the rate at which the energy is being created or the rate at which the energy is being destroyed. Okay, so two things are there. Whether any electrical device can either create energy, such as battery creates energy, it converts chemical energy into electrical energy. And one is that any electrical device is consuming energy. Like capacitor consumes the energy and stores it. Inductor consumes the energy and stores it. The resistor will also consume the energy, but it will not store. It will convert it into heat and other forms of energy. So basically the rate at which electrical energy is created or consumed is known as electrical power. Achha, remember one thing, whosoever is consuming the power, that is called as load. The device or the electrical device which is creating the power, that is called as source. So basically source will be converting some form of energy into electrical energy. Like if you take solar cell will convert solar energy into electrical energy. If you will take chemical cell or battery, it will convert chemical energy into electrical energy. Now you have to remember one thing, that whenever there is a source the current will always enter at the negative terminal of the source and it will always leave it from the positive terminal. What will be the power delivered by the source? The power delivered by the source will be voltage into current. Voltage means the potential difference across this source multiplied by the value of current. When you talk about load, it will consume electrical energy and convert it into some other form of energy, like basically resistor does what? It will consume the electrical energy and it will convert it into heat. So basically what will be the power consumed by the load? The power consumed by the load will also be equal to VI. So you have to remember only one thing, that power delivered by the source will be equal to voltage into current. The power consumed by the load will also be equal to voltage into current. The only difference is load is consuming that power and the source is delivering that power. The formula will remain same, that is V into I. So let's move to the next concept. If we talk about resistor, what will be the electrical power in the resistor? Always remember, the resistor will always behave like a load. It will always consume the electrical power and that particular electrical power, it will basically convert it into heat. So that electrical power is converting into heat, it will consume the electrical power always and convert it into heat. And always remember, whenever there is a load, in the load, current will always enter at the higher potential and it will exit at the lower potential. That means across a load, current will always flow from higher potential to lower potential. But across a source, current will flow from lower potential to higher potential. For resistor particularly, we already know that for any load, you can apply power is equal to V into I. But for a resistor, V can be written as I into R. So power can be written as I square R, or you can also write it as V square divided by R. So this is the power consumed by the resistor, power consumed by the load. Now how to calculate the heat dissipated by the resistor? So to calculate the heat dissipated by the resistor, if power is constant, the heat can be directly written as power into time, that is V into I into T, or I square RT, or V square by R into T. But if power is not constant, always remember, whenever there is a load, in the load, current will always enter at the higher potential and it will exit at the lower potential. That means across a load, current will always flow from higher potential to lower potential. But across a source, current will flow from lower potential to higher potential. For resistor particularly, we already know that for any load, you can apply power is equal to V into I. But for a resistor, V can be written as I into R. So power can be written as I square R, or you can also write it as V square divided by R. So this is the power consumed by the resistor, power consumed by the load. Now how to calculate the heat dissipated by the resistor? So to calculate the heat dissipated by the resistor, if power is constant, the heat can be directly written as power into time, that is V into I into T, or I square RT, or V square by R into T. But if power is not constant, then you have to integrate it. The heat will be given by